Okay, so here we're going to be talking about independent variables. Okay, so at first they kind of can be a little bit intimidating, but they're really not that bad. Your independent variable, that's going to be your fixed variable, or the constant, right? The same rule that always applies, or the thing that stays the same no matter what. It's represented by your x coordinates, okay, which is your independent variable is always going to be on your x-axis. That's really important to know, and it's sometimes called the control. For example, we have number or time and like number of items, right? For your dependent variable, the dependent variable is the responsive variable is dependent on the independent variable. It can be represented by the y coordinate and changes based on the independent variable. For example, your total cost, right? So we're gonna go into a few examples and talk about what that means. All right, but you'll be all right. So here, let's look at these first six and get going. Okay, it says Jameson runs M miles and burns C number of calories. Okay, for me, the independent variable here exists as the miles. Okay, a mile is going to remain a mile. I'm going to say number of miles, no matter what. Okay, um, so it really depends on Jameson how many calories he wants to burn. The calories are dependent because the calories rely on Jameson actually running these miles. Number of, I'm going to say calories burned. Okay. So easy peasy, but I don't want to just leave it like that. What I'm going to do is I'm going to build a small coordinate grid or plane, I guess. Okay, on this side is your x values, your y values, right? Your independent variable is always your x. I don't want to forget my origin point either, okay? So your independent variable is always your x-axis, therefore this represents miles, and this represents calories burned, okay? The more miles Jameson runs, the more calories he will burn. Okay, let's keep going. Number 2 says the more hours H Brady practices, the better his test grade G will be. Perfect. So the independent variable here is going to be H, the number of hours practicing technically, but we'll say number of hours spent studying, right? The independent variable here is going to be his grade, G. Really his, I guess his test grade can be it. His test grade only grows the more that he studies, right? So we're going to draw another coordinate plane here, or a grid, whatever you want to call it. X, Y axes, we'll label it like that. My independent variable is always going to be on my X axis. That's going to be, or I don't know why I wrote M. Sorry about that. That's going to be H for hours. And my dependent is going to be G for his test grade. And again, there's a correlation, a direct relationship between the more hours that Brady or anyone else studies, the higher their test scores get. All right, let's keep going. Number 3 says Michael pays $8 per month for his streaming subscription. Okay, so for his independent variable here, it's going to be the number of months because number of months, yeah. And really, it's his subscription per month, right? So because it's per month, it's going to be number of months. What's going to be dependent? Well, depending on how long he has the subscription for, his dependent variable is going to be the total cost, okay? Now let's go ahead and create a little grid. Label our axes. There's my x-axis. There's my y-axis, my origin point at 0, 0. My x-axis always represents my independent variable, which in this case is going to be, I guess we can say number of months. We can say M for months. And for our independent for our dependent variable, we can say C for cost, okay? Total cost. Again, you can see the subscription stays the same, or at least the cost of it, but the longer he has the subscription, the more his total costs will rise. Looking at number 4, a car travels 60 miles per hour. Okay, so here our independent variable will be number of hours. Okay, number of hours driven, really. And the dependent is going to be your total miles, right? Your total miles. So again, this car is traveling at a steady rate. Excuse me. A steady rate of 60 miles per hour. Okay. So let's build this little grid. X-axis, Y-axis, origin point. My independent variable is going to be number of hours. We'll say H for hours driven, and we'll say M for total miles. The longer or the more miles a car travels at, let's say, 60 miles per hour, the more total miles you will accrue, right? So yeah, I mean, the longer you drive, the more miles you put on your car. So that one actually makes a lot of sense. Looking at number 5, okay, it says each slice of pizza costs $6 at the football game. Okay, your independent variable here is going to be your number of pizza slices, right? The slices of the pizza stay the same, but your dependent variable, which is going to be your total cost, that depends on how many of those slices you actually buy. So again, let's build a little grid. Let's label X, Y, origin. Independent variable is going to be my X-axis. We'll say P for pizza slices. We'll say C for total cost. And again, the more pizza slices that you buy, the higher your total cost will be. Number 6. Number 6 is applicable to a lot of kids, right? Let's say we replace the name Jesse with you, right? The later you stay up at night, the sleepier you are at school, which works perfectly, okay? So our independent variable here is going to be your number of hours slept, okay? The more you sleep, the less tired you are, okay? So your dependent variable here is going to be basically your sleepiness at school the next day. So let's turn this into a little grid here. All right, we have our x-axis, our y-axis, our origin point right here. This is going to be hours of sleep. And here we'll put an S for your sleepiness. Now in this case, we want to think of it like, so if here's our X, this is 1. I'm not marking it, but let's say this is 1, 2, 3, 4, 5, and so forth, right? If you only had 1 hour of sleep, that means your sleepiness would be very, very high. You'd be very sleepy the next day. If you have 2 hours of sleep, you'd still be sleepy, very sleepy, just not as sleepy, not as sleepy, not as sleepy. The more hours you sleep, the less sleepy you are. The less hours you sleep, the more sleepy you become. Okay? So I like that one. That's a good one. It's a quick way to build these tables, graph a little bit, and then really hone in on which axis represents our independent variable and which axis represents our dependent variable. Okay, let's go to the next page. All right, this one's good as well. To fill in this little blank here, graphs and tables can also display. Okay, so we'll write that here, graphs, and I'm going to say tables, okay? They can also display independent and dependent quantities, okay? Now, couple things here. Let's see, let's switch up some colors for the sake of staying consistent. I still want to label, okay? So let's get brown, and we'll get this shade here. We'll figure it out. All right, cool. So I still want to label. Here's my x-axis. Here's my y-axis. Here is my origin point. Okay. Now, I also want to, off to the side, because we're going to get into this, okay? Off to the side, I'm going to build myself a X, Y, I guess T chart, you can call it. I'm extending this really long, okay? Because I also want to document what my coordinate pairs are, because that's going to help me actually with part D and C in this entire little problem here. So, with that said, let's get to it. What is the independent variable? Okay, well, that part's pretty simple. We've been saying it over and over and over and over again. The independent variable is going to be anything on the x-axis. What is our x-axis? Number of weeks. So we'll just say number of weeks, which makes our dependent variable anything on the y-axis. Our total miles run. Total miles run. Awesome. Excellent. Cool. Let's keep going. List the independent quantities. Okay. Well, in order to do this, we look at our x-axis, and everything down here is going to represent our independent quantities. Okay. But before we do that, what I really want to do is use the graph to find our coordinate or to find our ordered pairs so that we can answer C and D really super simple. So let's do it. I'm going to do 1 and 3, 2 and 6, 3 and 9, 4 and 12, 5 and 15, 6 and 18, 7 and 21. And by now you should start thinking to yourself, what is the relationship between my x value and my y value? What is happening between them? Is it multiplicative? Is it additive? Remember that multiplicative means both multiplying and division. Additive means both addition and subtraction. And if it is one of those, how much are they multiplying, dividing, adding, or subtracting by? Okay, so here we go. Let's start building. All right. My first set is going to be 1 and 3, 2 and 6, 9, or sorry, 3 and 9. There we go. Sorry about that. 4 and 12, 5 and 15, 6 and 18, 7 and 21, 8 and 24, 9 and 27, and finally 10 and 30. Here, I clearly have a multiplicative relationship, and the rule that's happening is times 3. Now, list all my independent quantities. Absolutely, you got it. That's going to be everything here on the x-axis, either way you want to see it. I'm just going to list them. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. All of my dependent quantities, my y values are here. They're also here. And I'm just going to list them as such. 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. Now, if we were to write an equation representing what we have here, we can say that the value of our y is equal to 3 times the value of our x, which again you can see is true. 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, and so forth. Let's keep going. All right, looking at number 8 and 9 before we get into 10 through 12, okay? 8 and 9, okay, so what I like to do here is I like to label. So what I'm going to do is, even though it has H and M, I'm still going to label this as my X value, and my Y value, my X value, and my Y value, and I'm going to do it here as well. X value, Y value, X value, Y value, one more, X value, and Y value. Okay, perfect. Now again, I know that each variable represents different things. However, the more we get into the habit of recognizing that the left of these charts are your X and the right are the Y's, the top are your X and the bottom are your Y's, the easier that translates as you move forward mathematically in your career. Okay, so our independent variable here is going to be our X. Our X coordinates, our X value, sorry about that. This is going to represent number of hours. Miles, okay, that's going to represent number of miles. When I talk about an equation, in order to find the relationship here, I would take the value of 130 and divide it by 2, which we can do. 2 fits inside of 130. 6 times, that's going to give you 12. You subtract, that's 1. Bring down the 0. 2 fits inside of 10 5 times. Therefore, you can say that y is equal to 65 times the value of x. And let's keep going. Next one, okay, independent is going to be number of months. Of course, it is our x value. Therefore, it's always independent. Dependent is going to be our total cost. And here we also have a multiplicative relationship. Okay, 1 times $3.99 every single time. That's what's being multiplied. Therefore, here we can say that the value of y is equal to $3.99 times your value of x. And then when we look down to 10, 11, and 12, again, all we're doing is labeling here, really. So all we're doing is labeling here. So notice how they're saying quantities. That's very important, right? These are your quantities, okay? These are your quantities. So again, independent associated with your x values is very important. So my quantities here are going to be 3, 6, 9, and 12. My dependent quantities are going to be 165, 330, 495, and 660. Okay, what's happening here is this is a multiplicative relationship, and they're actually multiplying by 55 every time. 55 times 55 times 55. All right, let's look at number 11. Here, my independent variables are going to be all my x values. I have 1, 2, 3, and 4. Here are all of my y values. We have 0.75, 1.5, 2.25, and finally 3. I'm just going to write 3 like that to save myself some space here at the end. Also, what's happening here is this is multiplicative. Okay, we are multiplying by 0.75 every single time. 0.75 times 0.75 times 0.75. All right. When we look at number 12, okay, independent quantities are going to be your x values, 16, 8, 4, and 12. Your total cost, 56, 28, 14, and 42. What's happening here is there's actually a multiplicative relationship of times 3.5 times 3.5 times 3.5 and times 3.5 every single time. All right. So I hope this one was super helpful too. See you later.